Hi, this is Oda from NASA's Jet Propulsion Laboratory. Today we're going to make a paper Mars helicopter. We have satellites in orbit around Mars that take global pictures, and we have a rover on the surface that takes up-close pictures. But there are some places on Mars that a rover just can't go. They're too rocky or too steep of a cliff. So the next Mars rover, Perseverance, is going to take a helicopter attached to its belly to the surface. When it gets there, it's going to deploy the helicopter. The helicopter will fly around for a series of test flights. If we're lucky, we might get some pictures of surfaces that we can't see with the rover. Now, these test flights are going to be really short, no more than about 90 seconds. And if they're successful, the helicopter will come back, land on the surface near the rover, convey the images to the rover, and then the rover will convey those to Earth where we can see them. The hard part about flying on Mars is the Martian atmosphere is so thin. It's only about 1% the thickness of Earth's atmosphere. What that means is if we were standing on the surface of Mars and there were a 100-mile-an-hour wind, it would barely disturb our hair. So it makes it hard for an aircraft to fly in very little air, because aircraft needs to be able to generate enough lift. Lift is the force that is applied to the rotors by the air that lifts the whole aircraft off the surface. The Mars helicopter has angled blades just like helicopters on Earth, so that when they rotate, they run into the air and cause a high pressure that will push those blades and the helicopter up into the air. Now, the Mars helicopter is very lightweight. It's only about 1.8 kilograms, and it has really big blades. They're about 1.2 meters wide, which is about 4 feet or so, and they rotate 10 times faster than helicopter blades do on Earth. Now, engineers had to do a lot of testing. They had to figure out what kind of a helicopter blade is going to help that helicopter get off of the planet. We have a chamber at JPL where we could pump out a lot of the air so we could test it in an atmosphere a lot like Mars. And we could also offset the gravity using a tether. Now it's time for you to make a Mars helicopter. You're going to need a few things. First, you're going to need either the printed template from this activity or a blank piece of paper that you can sketch that template onto, a pencil, a pair of scissors, a measuring tape, and if you have it, a little strip of ribbon. First, I want you to cut along the dashed lines as shown in this diagram. Then, take the rotors, which are labeled A and B, and fold them along the line shown in opposite directions. Next, fold in X and Y. Those two flaps will fold in to make the body of the helicopter. And then lastly, fold up flap Z so that your finished product looks like this. In order to fly your helicopter, you're going to grab the body and drop from any height that you choose. Now I want you to adjust the performance of your helicopter. The rotor blades are key to how your helicopter performs. So try making them smaller or building another helicopter and making them larger. Another thing that you can adjust is how they are folded. The angle of incidence that is formed between the rotor and the body can be changed and possibly impact the performance of your helicopter. For more ideas of how to measure the performance of your helicopter, take a look at the full activity at this URL and have a good time building your Mars helicopter.